Hello, everyone. Good evening. Uh, so we are going to start in a couple of minutes. So let's wait for some time. All right. So good evening, everyone. I hope I'm audible. If someone can, if someone of you can comment, that would be great. I hope I'm audible. And during the session, if you find that my audio is breaking or the screen is not visible, please send a note so that I come to know that there is some issue so that I can fix it out. Okay. So with that, let's get started. All right. So today, we are going to discuss about how we can deploy a machine learning model using AWS Elastic Beanstalk. So uh, we have many compute services and various ways that we can deploy our machine learning model. But what we are going to focus on today is how we can deploy a machine learning model wrapped around a web application. Okay. So my name is Suman Devnath. I work for the Developer Advocates team, and I'm based out of Bangalore. So this particular talk I have delivered one part of that in the Python conference a couple of weeks back. I just thought to share it, in our platform as well. So what we are going to talk today in next 30-40 minutes is we are going to build a small model using gradient boosting algorithm, and then we will train that model. It would be a very toy example, but the idea is how to show you how we can deploy that model over the cloud on AWS using Elastic Beanstalk. Okay, so this is what we are going to see. If the demo works fine, we should be able to see our application up and running after we deploy it on the web. So this application is nothing but a wine quality predictor. So we this data set is coming from a Kaggle, and it's there in almost everywhere. So what this model does is it predicts the quality of the wine. Okay, so given a data set which contains various parameters and features of a particular wine, and it categorizes it into different classes. So like uh, quality 1, quality 2, quality 3, and so on and so forth. So what we need to predict is we need to build a model, and such that given all the features and characteristics of a particular wine, the model should be able to predict the quality of that particular wine. So we are going to use boosting algorithm, one of the boosting algorithm that we have, and then we will try to deploy that over a web application using Flask. So just to recap what supervised learning is. So if you have attended many other sessions from me or from others in machine learning, you might have seen this million times. But just to recap, in machine learning we have two different types of techniques. One is supervised, another is unsupervised. So supervised is when you are given a data set with its class label, and you need to train the model in such a way that once the training is done, you can do prediction. You can predict and tell which class that particular instance or data point belongs to. Right. So this is what supervised machine learning is. So it's like this. So let's say there's an image, and this image contains baby, right? So the image would be the data point, and the baby is the class label. Similarly, this is a dog. So the image is a image of a dog, and the class label would be dog or labrador, whatever it is. So the way that supervised learning works is you are given the data along with its label. So always you pass the data along with its label, and you pass maximum amount of data, so as much as data is possible, because at the end of the day, the idea of the model is to come up with a model such that it can do better prediction. And since this is using uh, the input data that the model is will try to understand the patterns uh, in the input stream of data. So more the data is, better it would be to build your model, right? So once you have the input data and its labels, you use one of the other machine learning algorithm that we have. And like today we are going to use a boosting algorithm, but there are many other algorithms that we have, like decision tree, then k nearest neighbor, random forest, etc. So once you apply the model and feed the input data, then you get the prediction. Once the training is done, you get the prediction. So this is a very streamlined way of how you train a particular model in supervised learning. And once you get the prediction, you try to check your prediction is correct or not. So you basically try to see if there is any error with respect to the input data stream or the input class label, right? And if there is any error, then you try to change or see that if all the hyperparameters are correct, or even the algorithm is correct or not. And then you retrain the model again, right? So this is a typical life cycle of supervised learning. Now there are many algorithms that we have, and this particular chart covers almost most of the most predominant algorithms. And if you see here, there are a lot of algorithms which are supervised as well as unsupervised uh, machine learning algorithms. Like, let's say, use my pen. So like decision tree is a supervised one, ensemble is a supervised machine learning algorithm, then clustering is for unsupervised learning algorithm. PC is also, you can think of, used mostly in dimensional reduction. So when you have lots of features and you want to shrink it down based on some correlation, you use PCA. So this is also kind of we use it along the side of clustering. So today we are going to use one of the ensemble based learning, which is called boosting. So uh, there are a lot of different ensemble algorithms available. but the most predominant are boosting, bragging, and boosting. So we will be going over boosting today, but you can use any of the other algorithm based on the problem set that you have. Okay, so before we get into the boosting algorithm, let me give you an intuition of what that algorithm is. So to do so, let's go back and try to revisit and check what a decision tree is, because decision tree is used in boosting algorithms. So it's always good to understand what a decision tree is. So as the name suggests, the way the decision tree works is, so decision tree is also a supervised algorithm, learning algorithm, machine learning algorithm. And the way it basically works is, given a data set, what you try to do is you try to make a tree based on some decision. And the idea is, once you get to the node of the tree, you should be able to get the class label. Right? So uh, or node in the sense the leaf of the tree. So the idea is, you have to break your data set in such a way, based on the features that it has, that once you go to the leaf of that, you should be able to get the class labels, right? So the example here is, let's say you have this is a very small example. So let's say this particular data set contains the color and size of fruits. Okay, this image is not given in the data set. Okay, they just to show you what it would look like. But this is the data set that you have. So this input feature is X, and the Y is the output class label. So in the input, you have two features, right? Color and size. These are the only two features that you have, and this is the target label. Now you have to pick first. You have to pick in decision tree is which of these feature would be good to split the data, so that uh, I can predict the class in a better way. Right? So which feature to pick? There is a different technique that how you can pick the root node, but we will not go there today. I have written one blog last couple of months back. You may like to see on decision tree. But the idea is, once you pick the root node, like here it's color, then you branch it out based on the available domain. So the color could be red, green, and yellow. Now if you see, if you just check the red one, right? If you check the red one, all the red ones are apple. So you know that if any fruit is red, then that would be an apple. So I know that this would be the class label. So in later point in time, once the model gets trained, if you give any data, input data, and if the color is red, the decision tree would automatically will parse that data through this tree, and it will say that, okay, the class label is apple, right? So this is the intuition behind a decision tree. But if you look at this, with only two features, the tree depth is 3, right? This is level 1, this is level 2, and this is the root level. So you can think of it as a depth 2, or 1 excluding the root. But think about it, if you have if you have hundreds and thousands of feature, and every feature can have n number of classes, then your tree would be huge, right? But here it's very simple, because the color can be any of these three, right? Either red, green, or yellow. And the size can be any of these three: big, small, yeah, only big and small. So this is a very simple data set. But if you think of a real world application or real world data set, you would often see that the number of features are huge, and the decision tree doesn't work that well when you parse the data through one single decision tree. So this is why the new technique that we have in machine learning called ensemble based technique. So what that does is, basically we say that, okay, we will not pick one gigantic tree. What we will do is, we will make use of small trees. Okay, so in this case, we are just taking an example of decision tree, but in real mean ensemble can be different models. It can be decision tree, or it can be SVM, or it can be a linear regressor, whatever it is. So the idea is, all the you are not building one particular model, you are actually making lots of small models. Okay, so the idea about this is, you make lots of small models, and then uh, all of them you aggregate. So basically, let's say this particular tree, the first weak learner might predict a few of the data set, or might be good at categorizing one of the feature or couple of features, so that it would do its own work, and then you will use the second weak model to classify some different set of data. And that way, when you come up with the ultimate model, like, that would be a very strong model, and it can predict, in with much better accuracy or performance, right? And ensemble based methods are rampantly used in Kaggle and different, machine learning competitions. Now, there are different types of ensemble based techniques, and one of them is boosting. So in boosting, what you do is basically you take a decision tree as your base model. So here, just like in this previous example, we have weak learner 1, 2, 3, 4, 5, right? So here we have just taken three weak learners. Okay, so one of the one way that you can visualize this is, let's say, uh, you are studying in school or college. This is not a very good example, but just to give you an intuition. So let's say you are good at some section of your in few of the subjects, and some other friend of you is he is good in some other subject. Some other friend, she is good at some other subject. And let's say you are going for an exam, or you want to study together. Then if you divide your study within your friends, like, okay, you may say that, okay, chapter 1 to 5 I will do, chapter 6 to 7 you will do, and all of that. If you do like that, ultimately, if a problem comes, one of you would be able to solve. All right, so when you collectively see that how strong your knowledge base is, within that group, that is pretty high, right? Because given a problem, uh, one of you would be able to solve that. Okay, so similar idea here. So let's say you have one weak learner. Okay, so let me erase this. Yeah, so let's say here we have two types of data set, two types of class label. One is a triangle and one is square. So any given data point can be either triangle or a square. Now, this weak learner, this is actually the, if you look at this, there is actually a decision tree with one depth. So basically, this is also called as decision stump. Okay, so basically this is a threshold, and it just say if it is less than this, then it would be a triangle. If this threshold, any data point which is greater than this threshold, it would be a square, right? So this is how this particular classifier is working. Like, is a very weak learner or weak classifier. But if you look at it, when it takes a decision like this, you see that these 3 points are wrongly classified, right? These three blue points are wrongly classified, because as per this weak learner, it should belong to red class, but that is not true, right? So what gradient boosting does is, in the next iteration, so it's a sequential way that it learns. So once this model is trained, this first weak learner is trained, the whole data set is again passed through the second weak learner. And at that time, what happens is, it gives more weightage to this data point. Okay, so it says that, okay, initially you picked all the data with the same uniform weight. That means uniform, uh, I would say, importance. But the next time when you train the data point, give more importance to these three. And that's why the decision boundary came here, right? Now when it came here, you see that there are 2 points which are again misclassified, right? Which were actually classified correctly in the first iteration. So next time it gives more priority to this data point and this data point. Similarly, in the uh, third iteration, you get something like this, and in this case, you again get misclassification for these 3 points. So you increase the weightage for these three data point, and ultimately what you get is, this is the strongest one, where you are able to classify all the data points correctly. So combining the weak classifier you can build a very strong classifier. And in gradient boosting, you typically use a decision tree as your base learner. So whenever someone says base learner is nothing but the weak learner that you are going to use to make a very strong learner at the end of the day. Okay, so this is what gradient boosting is in a nutshell. So let's go and see that how it's how we can use this in our code. So what we can do is okay, so I have it in notebook. What's this? Okay, and this notebook is available, in the GitHub repo. So if you want to play around, you can, do so. So basically, let me increase the font size if it is visible. Okay, so first we are just importing few of the modules, very standard module, and we are going to use scikit-learn. We are not going to use SageMaker because the idea is not this how you make the model, but the idea is we will see how you can deploy this model, via a web app into Elastic Beanstalk. Okay, so first we are going to download the dataset. So we are downloading some dataset for red wine and some dataset for white wine, and we are just loading it into a pandas data frame. So this is how the data frame looks like. And if you see here, yeah, so the last column, the quality, this is the class label, or this is what we need to predict. So first thing that we are going to do is we are going to merge these two data set, because this we have downloaded from two different sources. So once we merge, we have to identify. I mean, we should have something to identify that which data point is coming from which data set, right? White or red. So that's why we are creating two one column called color, where we will store its white or red. Yeah, it's just a boolean data type. So I mean, just a boolean value that it will store, right? So once you concatenate, or once you merge the data set, so we have the whole data frame in wine underscore df. And if you see, we have 13 features, and out of that one is actually my class label. So actually it has uh, 12 features, right? And we can just do some data exploration by describe, just to see the mean, median, and if what is the max, and all of that. So this we typically do before we do any a normalization or standardization of the data set. So now if you see the quality, that this is the class label, right? What should be the quality of that wine? And if you see, it has um different quality, and there are different number of data points that it belongs to. So we see that the wine which has a quality grade 6, it has maximum number of data points, right? But the wine which is 9, which is actually the best one, if you would go to the documentation from where the data set has been pulled, there it says what is the significance of this number. Okay, so here we see that number starts from 3, but actually they say that the wine could be of any of these qualities starting from 1 to 9. Okay, so but although that means that in the data frame, or in the data set, we don't have any data which belongs to class quality grade of 1 or 2, right? It starts from 3. But this will also give you an idea that this data set is not that balanced, right? Because you don't have enough number of data point with class of 3 or class of 8, right? And this is very relevant when you see that histogram, right? So you see most of the data points belongs to quality group 6. So what we are going to do is we are going to do make some tricks. So we will go through all the data points and we will just chop all the data for I mean, we will chop all the data once a particular quality group is exceeds 500. Okay, so basically we don't want this skewed data, so we will just cap it to 500. So the data points for quality 7 would be 500, this would be also 500, this would be also 500. So we'll just cap it to max 500. So we are just doing this in this short for loop. So we are just iterating over all the data set, all the data point, and we are just counting how many data points you have for a particular quality, and then we are just chopping anything which is above 500. So we are just chopped it here. So still it is very imbalanced, because we have very less amount of data points for these quality groups. But what we are going to do is now we will we will categorize them internally. So we will say, since we have very small number of data points in for category 3, or quality 3 or quality 8, what we will do is we will merge these qualities. Okay, so the old quality 3, 4, 5 would we will consider them as 3. So anything which has 3, 4, 5, we will consider that quality as 3. Okay, this is the idea. So this is just data munching. We are just playing around to make our life little easy. We don't want to build a model with multiple class, because we don't have enough data point to train the model, right? So let's do this, and once we do this, we see that it is still little better now, right? It is still imbalanced, but it is little better, right? So intuitively, if you think, uh, any wine which is of quality 9 is of very high quality, anything which is 3 is very low quality, and 6 is kind of medium, right? Because 6 we have not changed. If you see here, 6 we have not changed, but we have merged anything below 5 and anything above 6, right? So this is a good, medium, and bad. So now we have a distribution of data set, or the data that we had initially downloaded. And now what we are going to do is, if you see, we are going to split the data set into train and test. This is as per the normal practice for before we do any training. So we are going to use scikit-learn for this, and we will just split the data set. Okay, so once we are done with splitting, what we are going to do is, okay, did I miss something? Okay, yeah. Once we are done with this, what we are going to do is we are going to use the gradient boosting classifier for uh, to train our model, and we will pick it from sklearn ensemble. This is the package that we are going to use, and here we are saying that max depth is 10. So this is nothing, because here we have to actually we are not mentioning what should be the base classifier, right? So but because the gradient boosting, it uses a decision tree as its base classifier, and what we are saying is, for every time when you train the model, I mean, in every iteration, uh, use maximum 10 depth of the tree, right? And after that, you just stop it there. Whatever wherever you have reached, you just keep that cap at depth 10. Okay, so in if you just go back and look at this, so we are saying that here the depth is 1 2, right? So it can go till 10 and then it should stop. So although we have many features and the tree can grow beyond 10, but we are just saying that, okay, you just stop there. Okay, so this is the most interesting part, what I wanted to show you. uh, Once you create that object of the model, you do the fit. So we do if you actually are doing the training at this point, right? So you have started the training, and once the training is done, what you do is you save that model using pickle. So I'm just using pickle. Pickle is a module package available in Python, where you can actually dump any of the data type, and then you can reload it at any other place or at any point in time, right? So you can, so what you are doing is you are dumping it, and you are then saving it in some location. So this is my model artifact, if you want to think about it. So this is what my model is, which I have just trained, and I have just dumped it into one location. Okay, and this is the model we are going to use for inference at later point in time. Okay, so once this is, so we are actually done at this point. Okay, so whatever we are going to do from here on, it's just to see that how our model is. Okay, but as far as the model deployment is concerned, we are done at this point, but we should not stop at this point, because at this point we don't even know how good or how bad our model is, right? So let's make some prediction. So we are just sending some X test data. That is, these are the test data that we have saved. So if you remember, in this point, at this point, when we split the data set into test and training, we use 20% of the data set for testing. So we are just using those 20% of the data to test our model. And let's see that how our model is doing. So let's say this is we are just picking one of the uh, prediction of the data set that we have passed. So we passed the whole test data, and it is saved in pred, right? This is the output of the prediction. And now if you see the first element which was tested, its prediction is this. Okay, and this is nothing but a probability distribution. So we have three different classes of quality, right? 6, 3, 6, and 9. So this is saying the probability of all these three classes. So it says that uh, this particular data point, the first data point, it has a probability of 50% that it belongs to quality 3. It has a probability of 47% to it belongs to quality 6, and 0.01% or 1% that it belongs to class 9, right? So what we always take is the max of that, right? So we need to pick the class based on the maximum probability. So that is what we are doing here. We are just taking the argmax, and we see that the quality is 3, right? So this is what our prediction is. So now if you check the precision, so precision is one of the metrics that you use to find that your model is good or bad, and it says it's 74%. It's not at all a good model, but because we have not trained it properly, we don't have much data set, and we have not tuned it as well. But this is what the precision score is. If you want to check further, you can see the performance of it using something called confusion matrix. And if you in the confusion matrix, what it says is uh, in one side, or in x-axis, you see that it is a predicted class. In y-axis, you see the true class label. So this is the actual class, and this is the predicted class. And how you read this box is you pick any box, like let's say this green one. So green one says that it should be how many data point is actually a class belongs to class 0, and you have also predicted class 0. So the more you have in this block, in this green block, that would be good, right? So similarly in this second block, yellow one, how many data point is of actual class level 1, and you have also predicted as 1. So in a very ideal case, you will see that most of the you will have very big numbers in the diagonally in this confusion matrix, but very less numbers, small numbers into this off diagonal block. So that would suggest that your model is predicting pretty well. But since our model precision is 74, so almost 26% of the data is misclassified. Now if you sum this all, like 107, 6, 48, 78, 7, and 96, if you sum this all and divide it by the total number of data points that we have, you will find that it is actually 26%, because these are the errors, right? All these off diagonal blocks. Okay, so um, now if you want to predict make a prediction for a new data point, you can what we can do is we can save we can actually pick the data points from the user, and we can just call the model. So let me show you that. Yeah, so this is what we are doing. So we are actually fixed acidity, and all of these features, right? All these features we have identified or saved here. Okay, and we are just making a new data frame which contains all of that, and then we can do a prediction. The reason that we are doing it here is because this is how we are going to fetch information from the end user or through the web app, okay, that we are going to see. This is not that important, but I just kept it in the notebook, so I just thought to show you. Okay, so this is actually just one data point, and once you call that same model and try to do the prediction, it will give you the probability distribution of that particular data point. Okay, and then you can always do that argmax and pick up uh, the class, right? So the idea of this is the main objective of creating this model is this, that we have trained this model, and after that you save that model into your local repository, or in your um, file system, and now we are going to use that in our Flask application. So before that, let me go back to my slide. So now let's say we want to deploy we want to deploy this model via an Flask app. Okay, we will see that in a moment, but before that I just want to tell you that how you can deploy this. So in a typical environment, how you can deploy any web application is you need to find some resource like compute, storage, database, and all of that. And then once you know what are the resources that you want, you will provision all these resources, right? So maybe you want to have a EC2 instance, and you might want to have some storage, you might want to have load balancer, you might want to have some network configuration in terms of VPC, etc. And once you configure everything, you deploy your app, right? And after that, you keep on managing it. So over the period of time, you change your code and you have to push it. And when you push it, you again have to make sure that your application is upgraded properly, right? So this is the whole life cycle of deployment on the cloud. Now you have different options for different entities, right? So for storage, you have different options available like S3 or file storage, elastic file storage, or in database you have NoSQL database or relational database, etc. So this is quite a amount of resources that you need to be aware of, right? And if you are new to AWS, or even if you are experienced, it is quite a difficult task to manage all this resource, and deploy it, right? So this is where Elastic Beanstalk comes into picture. So Elastic Beanstalk, you can think of it as a platform as a service kind of. You can compare that with that category of infrastructure, where you we will be giving you a platform, and you just come and dump your app and your data, and your application would be up and running, right? So all of the heavy lifting of storage or infrastructure or virtual machine and load balancer, everything is taken care by Elastic Beanstalk. All you need to come up with is your application and your data. So these are the two things that you basically need to deploy your application in Elastic Beanstalk. Okay, so it works very simple. If this is through CLI, so you have once you install the Elastic Beanstalk CLI, you can just do EB init, and once you do an EB init, it creates an application. So this is the application that you just instantiated, and then you do EB create. So what you do in EB create is basically you create the infrastructure needed for your application. So you can specify what type of application you are going to run. So in our case, it would be Python. So you mentioned that you want to deploy an application which is written in Python, in which region you want to deploy, and all of that. So this is we have not given the options, but basically, this is the command that you can use to create the resources. And once this is done, then your application would be up and running, and you don't have to manage all the resources. So everything would be instantiated automatically, under the hood. And once you are done with that, if you want to deploy your application, sorry, if you want to update your application and then deploy, you can just use eb deploy. Okay, so let's see that how it uh, works. So now before I switch in there, let me close the Jupyter notebook. So to this folder, if you see here, we have an application, right? App.py. And if you go inside pickle, you will see this model, right? The model that we have created using that Jupyter notebook, right? We just save that model uh, into a pickle object, right? So this is that model we are going to use. So now let's go back and see what that application, how that application looks like. Okay, so this is the application. This is a very simple, Flask application. I'll just minimize everything so that there is less clutter. Okay, so this is the whole Flask application. So what is important to see is this. So we are importing that GMB underscore model. Okay, and then, I mean, not importing, we are just declaring that it's a global variable. So this is what we have instantiated first place, and then we are just loading using pickle. So we are loading with that same location where we have saved. So at this point, this GBM underscore model is exactly that model that we have we have trained. So we can now do the prediction by taking input data from our user, right? And how we are taking the information, we are taking all the features like this. So, and if you remember, this is exactly what towards the end of that Jupyter notebook, we were saving all the input data from the user, right? So we are just saving all these features which are needed to do the prediction, right? So everything we are taking from the user, and then we are saving it in a data frame. If you remember, this is exactly the same code that we have executed in the Jupyter notebook. All right. And once you have that data, you can do the prediction, and you can call the same GBM underscore model to do the prediction. And once that prediction is done, the prediction will give you 3, 6, or 9. So this number is not that easily understandable. So what we are going to do is we are going to print low for 3, medium for 6, and high for 9. So we are just creating a lookup hash, and then we will just return the JSON for that, and which will be ultimately printed by our the index file. Okay, we will just parse that into the index file. So this is just the HTML file, so it's nothing fancy there. So very simple, Flask app. Okay, so now let's go back, and so we are let me just this. Okay, so now we are into this folder where we have our app, and the our model which is saved in this pickle, and we have some images which are used in the web page, the index.html. Those are saved in static folder. So everything that is needed for my app to run is saved here. Okay, so the first thing that we need to do is we have to create a virtual environment, right? So uh, let's create that. Okay, and next is we need to activate that virtual environment. I'm actually in that virtual environment, but still, doing it to show you. So now we can install, all the dependencies that we have, in the requirement. So we can do pip install we are done. So all our, all everything is installed. So that's why it is saying that nothing to be installed. Okay. So now what we want to do is we will instantiate. Just 1 second. We will instantiate an application. So the way that we can do it is using EB init, right? So for that, and run this. So this is what we are doing. We are doing EB init, and we are saying that it is a Python application, and we are giving some name like wine demo, and we are specifying the region. So this will create an application for us, right? So now, if we go to our UI, if you go to our UI, and this is our Elastic Beanstalk, splash screen, the welcome screen. If you just refresh and click on application, you see that we have just created now, but there is no environment. If you click on this, there is no environment here, right? Because we have not yet, created any environment. So let's minimize this. Okay, and now we need to create that environment. So how we can create that? We can say eb create. So we can give some name, Flask env wine demo. So before I run that, I want to show you something. Let me comment this. Because of this first command that we have created, right? So if you see, you will find an hidden file, right? And if you go to this folder, you will find a file called config. And if you see here, all the information that you have passed in that command, like it should be a Python file, and this would be the region. Everything is mentioned in this config file. But the environment, it's nothing is defined, right? So once we create the environment, we would see that this file will get updated. Okay. So now let's go back in the present working directory, and we can just create. Now what would happen is it will try to allocate resources for our application. And for that, first what it would do is it would zip all the content that it has in the present working directory, and then it will save it into the cloud in S3, and it will create an instance for us in EC2 instance, and with all the dependencies. So whatever we have mentioned in requirement of text, everything will be installed, configured for us. And after that, if everything works fine, after that we should be we should be getting an endpoint, and which can direct us to the web application, right? Although we can do a lot of things, like we can add load balancer and auto scaling and all of that. You can do everything, right? So whatever you feel like, a lot of things are configurable, and you can control that. But this is how simple it is to create a web application on AWS, right? So let's give us a minute so that. So in the meantime, if you have any questions you may like to ask. Okay, there are some questions. Will the notebook be shared? Yeah, notebook will be shared. So let me, by the time this is happening, let me just share you that. Give me a moment. So you can just, I'm just posting it. Okay, I hope you got that. So I posted in, I guess it went to uh, uh, YouTube live, not in Facebook. So what you can do is you may like to note this up. Maybe I'll put that in the presentation itself. So basically, this is the GitHub repo, DBNSUMA PWC 2020. Okay, this was, since it was we used this in the Python Web Conference, so that's why it's still the same repo. Okay, so all right, let's see where are we now. Okay, it's still creating. And one other thing is that if you see here, it is creating an auto scaling group for you. It is creating an EC2 instance, and you have not done anything, right? So everything, by default itself, we have not given any of the options that how many instances, maximum number of instances we want, how to scale. We have not mentioned anything, but it is already creating it for us, right? And you also see that uh, you have uh, you know everything, all the logs is going to CloudWatch. So let's go to our web console and see that how it is going. Okay, so let's let's go to application. So let's refresh. So if you see, now we have an environment, but it is still in pending state. So let's go to our environment, and it's still still in progress, right? So in the meantime, what I can show you is, let's go to EC2 and see that if it's actually creating an instance or not. So if you see here, it's saying running instance 1. So let's go there and see which instance is running. So this is the instance that it got created by default, and by default it uses T2 micro. And you see that it is still in initialization stage, right? So once it is up and running, then we should be able to see our app as well. So in this instance, whatever code that we were running in our laptop, it is all there. And whenever you do any upgrade, right, or any update of your code, it will just go there and it will update. Okay, so this is how it will work under the hood. So let's give a couple of more moment. I hope it will be ready in some time. Let's go back to Beanstalk. And now it looks like it is done. And in the command line also, it says it is done. But I don't want to open it from UI. In command line, you can say eb open. Okay. So once you hit this, it will automatically go to the endpoint, right? So this is the endpoint, and the same thing you would actually see, here. If you click on this endpoint, this URL, there is the exact same URL that we got when we ran EV open, right? So now, if you see, this is a slider that we have. If you just change this, and you see the difference here, right? If you look at this low, the title of this image, and if you change something, and you will see that how it is changing the prediction, right? So this prediction is coming from the model, right? And the inference is happening every time you are changing something, right? And now let's say, if you see here, the tags that we have is medium, or it is low, or I guess it should be high. Let's see how we can get to some high score. Okay, let's do this. Let's say we want to change this low to very low. Okay, so what we can do is, let's try this out. Okay, so let me open this application. Okay, and let's change this to very low, very low. So let's say, you just think about it, that I've changed, make some change in the code, right? And then what we can do is, uh, now if you see here, our application got changed just now, and now we can do eb deploy. So now it will again, now in this case, it will not create all the infrastructure like EC2 instances and all of that, because it's already there. But what it will do is, it will just take this change, and it will just zip this code, and then it will just push it to that instance, right? So it should be reasonably quick. But during this time when this is happening, right, your application would be up and running. Okay, so I did not touch upon one thing, in that is how it upgrades the application. So there are different ways that it upgrades the application, which I'll show you in a moment before we end this session. But all I wanted to show you is, while this upgrade is going on, it is very much possible that you will not find any downtime, right? There might be, based on different policies that you set in, which we are going to see now, you might see a little bit of performance degradation, but all depends on how you have configured it. But in our case, we 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 did not see any difference, right? Because now uh, we changed that application, changed the application code, and now if you just let's see this, now it is very very low. So I have not even refreshed this page, right? I will just keep on playing with this, and I see that the application code has been changed successfully, right? And now let's go back and see that how it does the upgrade. So if you come to this application, and if you go to configuration and come to upgrades, okay, rolling upgrade and deployment, and if you click on edit, you will see that there are different types of upgrades, deployment policies available. One is rolling with additional batch, one is immutable, and one is all at once, right? So by default it is all at one or all at once. And what that means is, uh, in our case, our application is deployed in only one instance, right? So it is only one. But in ideally, in the real world example, your application will be deployed in tens or hundreds of instances, right? So when we say all at once, what it will do is it will upgrade all, and once the upgradation is completed in all of them, then it will just take a switch. And so it will there will be a fraction of second of cutover, and then it will go to the new version. Okay. And rolling is where it will do in a rolling fashion. So it will upgrade one of the instance, and then upgrade the second instance, then it will upgrade the third instance, and all of that. And since we are using this web app under a load balancer, it might happen during that time while you are upgrading. It might happen one of the user will get the older version of your app, and another user might get a newer version of your app. Okay. So there won't be any performance implication as such, but there might be some difference in terms of what the user gets during that rolling upgrade time. But to have it, if you want to avoid any such case, or you if you want to avoid the performance issue while that upgrade is happening, you may like to use rolling with additional batches, okay, where it creates a new set of instances to upgrade your with the updated code. And once everything is ready, then only it dismantles all the older instances or all the older machines, okay, with older versions. Okay, so this is how it works. So you can configure all of these as well. So that's about it. And now so if you look at it, it has created a lot of configurations, right? Lots of resources, instances, then load balancer. For monitoring, it uses CloudWatch. All of these are configured automatically. I have not even went to any of these resources, right? Now if let's say you are done with your project and you want to dismantle that, you can just do eb terminate. So once you do that, it will ask you for confirmation of the name of the environment, and once you provide that, it will automatically dismantle all the resources. So you don't have to worry about going back and cleaning up your infrastructure. Okay. So once this is done, from my UI, nothing would be visible. Everything, the whole environment will be gone. Okay. So that's about it. So I just took some screenshot just in case demo doesn't work, or maybe due to some internet or something. So I just took some screenshot just to show you that how these things actually work. Okay, so this is the same thing that we have covered. Okay, so that's all from my side, and I wanted to show you something else as well, but maybe I'll park it into uh, another session, where you can pick the same application and you can host it via container, or in Fargate, or even as a Docker container within Elastic Beanstalk, or in Fargate, which is our serverless offering for containers. Right. So maybe I'll do that in some other session. But you may like to scan this. You will get some credits, and as always, if you find that code is not working, just ping me in LinkedIn or Twitter, wherever it is, because I've seen that a lot of people having some issue in getting a wrong code. So I will fix it. So I always respond to everyone whoever complains about this code. So, but do use make use of these free credit codes to play around. All right. So with that, thank you so much for your time. I hope that you got a little bit of intuition about how Elastic Beanstalk work and how you can deploy your model. We did not go through the depth of the Flask application, uh, but the idea is not about you are using Flask or Python. It could be any programming language or anything. So basically, Beanstalk supports a variety of programming language, like Node.js, Java, Python, Go, and all of that, even containers, right? So once it supports container, that means that you can actually do any application, you can develop any application, right? So because container can run almost everything, right? So uh, just play around with this, and feel free to reach out to me in case you face any issue, or in case you want to learn more. We would love to hear from you. Okay, so with that, I guess I'm done. If you have any questions, let me check the questions. Okay. Okay. Will you want to someone Pawan is asking, can want to see some deployment of object detection? Okay, sure, we can do that. So that's a good input. So we will try to use some model for object detection. So maybe we'll use some CNN for that, and then we'll try to deploy it. Right. Okay, that's a good input. We'll play around with that. Okay. So all right. So there is one more question. I did not get that. Uh, I did not get that. I think someone asked uh, Q libraries. I did not understand that. So if you can ping me separately, I would be able to answer that. Okay. And the other question is the notebook is shared? Yeah, it is shared. Already shared that. I guess it is now shared in Facebook as well. So I guess Partha Rohini might have shared that. Thanks for that. Um, is Elastic Beanstalk is a free service? Yes, it is. Okay, I did not mention that. Yeah, it's a free service, and the idea about this is basically it's the automation, right? So everything is automated, so you don't have to worry about how the resources are deployed. You will be charged for the instances that or the resources that the Beanstalk is using. Okay, so you will be charged for that, but you won't be able charged for anything on Beanstalk. Okay, so you'll be charged for the resources that you have created. Like in my case, what we have done is now we have just deleted. But if you go to EC2, this particular Beanstalk stack was using one EC2 instance, right? And we ran that for roughly 20 minutes, right? Now it is terminating. The reason it is terminating is because we ran EB terminate, right? So we are charged during this last 20 minutes. It will be charged for those 20 minutes, right? So although I won't be charged because let's say I'm in free tier and I'm using T2 micro, I won't be charged. But you won't be charged for Elastic Beanstalk, but you will be charged for all the resources as applicable which you use within the Elastic Beanstalk stack. Okay, I'm new to machine learning. How we can get started? So there are multiple ways that you can get started with, but I would recommend this website that we have, ml.aws. So it contains lots of resources, and this also contains our machine learning university, which was previously accessible to only employees. So you may like to go over that, and all the trainings are freely available there. So let me check that if I can get that exact link. AWS machine. So yeah, I guess, yeah, this is the one. I think this will have the link. So, and this will also give you some background about that. So let me post that to you. I guess it would. Yeah, I think it went to Facebook as well as YouTube. Okay. So this is a good place to get started with, but I would recommend, if you're new to machine learning, you may pick any other resource to learn the some basic things on machine learning. There are n number of resources available in the internet. You can pick whatever suits your need, and if you're still overwhelmed with a lot of information, you can ping me. I will try to help you based on the background that you are coming from. But once that is done, you can actually go over the machine learning university, and there also you will see a lot of resources which starts from scratch, starts from the basics, right? So that would be useful as well. And we do have an AWS machine learning certification. If you're interested for certification, you may like to explore that as well. And by exploring that, you would be able to learn all the different machine learning services that AWS have. Right, so that would give you some intuition about how machine learning works in AWS or in cloud in general. Right, so that would be useful. Okay, so all right, so uh, that's all, I guess. Thank you so much for your time, and you have a wonderful evening ahead and a fantastic weekend. Thank you so much for your time, and I'm looking forward to get more questions from you. Feel free to ping me over LinkedIn or Twitter. I would be happy to help you. And one more thing before we close our day, I want to share something. So one of my colleague, Rohini, she's based out of Mumbai. She's starting off uh, her own YouTube channel tomorrow, and she will be speaking to one of our AWS trainer. And I guess, Pawan, a lot of your questions you might get answered tomorrow if you join. So you are new to AWS and you want to know about how you can deploy things and certification and other things. So I guess this session would be useful. This is scheduled for tomorrow 5 p.m. So feel free to log in and check, and you may like to reach out to Rohini or me at any point in time, right? So this is something that, if you're free, if your time permits, please join. I've shared that link over over the chat. Okay, so with that, I will call it a day. Thank you so much once again. We'll talk to you soon again. Thank you.